Chairman, for your kind introduction. Good afternoon, everyone. My name is Hideki Sugishima. I'm in charge of environmental research for jogmec, Japan. I'm glad to have this opportunity to present to you. Today, I would like to talk about our environmental baseline study conducted by jogmec. This is a outline of our presentation, background, survey period and area, and survey method and near-final sample processing, result, and summary. January 2014, the expression contract of cobalt-rich products was signed between jogmec and the ISA. This explanation contract period is 15 years, and the target area was located in northwestern Pacific Ocean. This picture shows the signing ceremony in Tokyo. This picture shows Japanese license exploration area of cobalt-rich rust. Sorry. The licensed area is about 600 kilometers southeast of Minami Torishima Island. And Minami Torishima Island is easternmost territory of Japan. 150 blocks are licensed. One block is 20 kilometers square. This figure shows typical example of potential environmental impact of deep sea mining. As everybody also know, environmental impact for deep sea mining have many influences like this figure. I think that major direct effect given to neofauna have two below impacts. One is directly destruction by mining tool unit. The other is the sedimentation of certain solid due to plume formation in the bottom layer. In order to know the present status of the environment of our target area, government is conducting environmental baseline survey in the area. Target deposits are seafloor massive sulfified, cobalt-rich rust, and rare earth sediments. This picture shows research vessel used in the survey. We have conducted environmental survey using this research vessel named Hakurei Maru number 2 to 2012 fiscal year. This picture, outline of this vessel were shown on this picture. From 2013 fiscal year, jogmec have operated new research vessel named Hakurei to conduct environmental survey. So a accurate picture will show at the end of this presentation. To collect the environmental baseline information of the sea mount where overbridge growth occurred, we conducted the environmental baseline survey at JA02 seamount from 26 to 2011 fiscal year. Conducted survey are measuring for water current and velocity, sediment sampling, and observation of seabed using FDC. The FDC means deep sea camera with finders. In addition, megafauna samples are collected in 26, 7, and 9 fiscal year at the JA02 seamount. This picture shows sediment sampling area on JA02 seamount. The point on this figure shows sampling points of each year. Sediment samples are collected by using multiple core. Core samples are cut into 10 layers of 1 centimeter thick. Chemical substances and organisms are analyzed. This is about megafauna sample processing. All the samples are fixed by 10% chromarine with rose Bengal. Megafauna were separated by using 300 micrometer and 32 micrometer sieve from sediment. Megafauna were identified into taxonomic groups and counted by using microscope. Result. This table shows taxonomic composition of megafauna in JL2. 8 phylum, 4 classes, 7 orders, and 5 families of animals were identified in JL2. Megafauna collected in our survey was identified above the family level. These pictures show dominant taxonomic groups in our survey. Dominant megafauna are these 3 groups. This figure shows abundance of megafauna in JL2 each year. The vertical axis shows the average number of megafauna abundance, and the horizontal axis shows each year. The abundance unit is number of individuals per 100 centimeters square. The dominant megafauna taxa were Nematoda and Arthropoda. Nematoda is over 90%. There is no clear difference in megafauna abundance each year. These figures show vertical distribution of megafauna in JA02. The vertical axis shows the depths, and the horizontal axis shows abundance of megafauna. Total abundance of megafauna was higher in upper layers, 0.2 centimeter. Abundance of arthropoda was particularly higher in 0 to 1 centimeter layer. Now, let me summarize our presentation. jogmec will continue to conduct the environmental baseline survey as an explanation blocks in accordance with ISA guideline. In order to know the environmental characteristics of our survey area, it is necessary to analyze the seasonal or interannual variation in each environmental item by comparing with other areas. We also think that it is important to train taxonomic technical workers. Size of marijuana is so small that it demands many time and higher skill to observe them. So I think that should be necessary to build a system for training the taxonomic technical workers. This vessel is Hakurei. Thank you for your attention. Thank you.
We have time for some questions.
Thank you. I've got a comment and a question. Actually, one is about the sieve size. We heard about the lower mesh size earlier, and I wonder about the upper mesh size. I know that the ISA has put the definition of meiofauna as anything smaller than 250 micron, but we're missing a lot of meiofauna if we exclude things that are retained on the 250 or 300 micron. And I know that seems like people are doing things a bit differently. Some people are not using an upper mesh, and some people are using an upper mesh, and I think that's we need to decide what to do. So that's a comment. And my question is, I'm not very familiar with crusts. How I would have thought that there's no sediment or not much sediment where the crusts are, or is there? Are they buried under sediment, or are you sampling areas beside the actual crusts, or?
They select the top of the seamount. There are the same note on the top of the seamount. So he selects that. Because there are many cracks and area on the slope the side of the seamount, but they can't take the sample by algebra core, so they take the top of the seamount.
I have a question about the sampling site. If there are different habitats, because I mean, in a seamount, you can have a summit that's completely different from the flanks, it's completely different from the basis. So, if I can see the map, it seems very big, different sampling locations. So, I'm wondering if there are different habitats, or are all the summit are only
About
so at the same depth? All the station?
about 100 kilometers. So
There's another question.
You are explaining your density in 100 centimeters square meiofauna. Is there a specific reason for that? Usually it is 10 centimeters used. Do you have some specific reason? Because the meiofauna, if you extrapolate in larger area, error is going to be increased. It is always better to be realistic so that you know actual numbers what you observe.
You must change.
Sorry, I don't have now detailed information about the question. I will check it and contact you later. Sorry.
It was just a comment regarding the cost and the question about the cost you were mentioning. I don't know about your specific area, but in the CCZ we have also presence of this manganese crust. You know it, and I think the origin is because of the hiatus of sedimentation, non-sedimentation, during a period which were, I think, more or less around the Miocene, medium and upper Miocene, so 5 million years ago. If we consider the low sedimentation rate, it seems that then you don't have so much sediment on top of it. Just a comment.
That makes it tricky, but doesn't it?
If there is no other comment, no more question, I'll thank you very much.